Today we're starting a new unit, factoring, and for some of you, you're going to breathe a sigh of relief because you learned factoring in Algebra 1 at one point in time, and hopefully those skills that you had then are going to come back to you quickly. In the study of algebra, there are certain skills that are called gateway skills, because without them, students simply cannot enter into many more complex and existing problems. And probably the most important of those gateway skills is factoring. I usually say that it's the #1 skill that you take with you to college algebra or to pre-calculus. The first method that we're going to talk about today is called the greatest common factor method. And the very first step when factoring is always to take out the greatest common factor. And that's also known as the GCF. Greatest common factor there again. Just a little bit too big for a space here. But I'll slide it over. If possible, you always want to take out a greatest common factor first. And then we try to factor the rest of the polynomial. When you're taking out a GCF, you find the biggest number that can divide into the given numbers. And the greatest common factor of variables is the smallest term with exponents. And we'll see that here in a couple of examples. But the first example is we want to factor completely, and it's 5x plus 10. And probably back in Algebra 1, what you might have done is you might have rewritten this as 5 times x plus 5 times 2. 5 times x and 5 times 2 are rewriting 5x plus 10 in terms of prime factors. And what happens is the greatest common factor is what is in common in both. Well, there's a 5 in both, so we can call 5 the greatest common factor. And then to finish the problem, we're going to write down what we haven't been able to make a greatest common factor, and that's the x plus 2. What we just did, we took out the greatest common factor. That was, the 5 was the biggest number that divides into both 5 and 10. So if you don't want to write it all out like that, we can do the same thing here with problem number 2. It's 6x plus 15. Well, what's the biggest number that we can divide 6 by evenly and 15 by evenly? And the biggest number that we can divide both of those two numbers by is 3. 3 goes into 6 evenly, 3 goes into 15 evenly. When we factor out that GCF of 3, to figure out what still remains in the parentheses, we take 6 divided by 3 is 2x, and we take 15 divided by 3, which is 5. Again, for some of you this might look quite familiar, and for some of you it's been 2 years since you've seen it and you might have forgotten it, so we have to learn it again. Example number 3. We need to look for the greatest common factor of 10 and 25, but we also need to look for the greatest common factor between the x squared and the x. And I want to write these out again. 10 is 5 times 2, and x squared is x times x. 25 is 5 times 5 times x. And as we look back at that, what we see that's in common in both, we see a 5 that's in both, and we see an x that's in common in both. So when we write our greatest common factor, it's the value that we circle. We only write it down once. 5 times x is our greatest common factor. And then we're left with the stuff that we didn't circle. 2 times x plus 5. Now again, that's a long way, and it's a good way, especially if you get in a situation where you panic and you forget how to do it. If you write it out, that might be helpful in trying to remember something. But once again, when we're looking for the greatest common factor, we want the biggest number that can divide into, in this case, into 2, into 8, into 10. And hopefully what you recognize is that 2 and 8 and 10 are all even numbers. So the greatest common factor of the numbers is 2. Well, when we look here in our first term, we've got x squared, and our second term is x, and then we have the 10. Well, we don't have an x term in all 3 positions. We have 2x squared, so there's an x in that term. 8x, there's an x in that term. But the 10 is a constant value. It does not have an x. So we're going to factor out the 2 of the GCF. So 2 divided by 2 is 1, x squared. 8 divided by 2 is 4x. And 10 divided by 2 is 5. Turns out, on problem number 4, that we actually can do more to that problem, which will be coming soon. We can factor more, but today I simply want to look at factoring the greatest common factor. What's in common in all of our terms that we can write out in front of the parentheses? And by the way, sometimes people call this reverse distributive property. Because if we multiplied x squared by 2, we get 2x squared. And if we multiplied 4x by 2, we get 8x. And if we multiplied 2 times 5, we get 10. It's the reverse of the distributive property. But let's keep practicing with the greatest common factor. And again, when we look at these, we want to find the biggest number that, in this case, goes into 8, into 12, into 20. And the biggest number that goes into 8 and 12 and 20 happens to be 4. Well, then we go ahead and we look at our x's. And we have x cubed in the first term, x squared in the second term, and x in the third term. We do have an x in every term, which means we do have a greatest common factor. And back there at the top of our notes, the greatest common factor between variables is always the variable with the smallest exponent. So we have a 3 as an exponent, a 2 as an exponent, and we just have x alone, which means x to the first power. So our GCF of our x terms is just x. Well then, to finish our factoring process, what we're going to do is we're going to divide. 8 divided by 4 is 2. And then the way I tend to say this is, for the x cubed, we started with 3 x's. We took out one of the x's. How many do we have left? We have 2. For our numbers here, 12 divided by 4 is 3. We had 2 x's. We took out 1 x, which means that 1 x remains. And in our last term, 20 divided by 4 is 5. We had 1 x originally. We took it out. It's out in front of the parentheses now, so we don't write any more x's back into our problem. Greatest common factor. Problem number 6. Same idea here. And in fact, I probably should have written it out longhand on that previous one. But what do 6 and 15 and 21, what factors do they all have in common? And remember, we want the biggest one. So that number has to go into all 3 of them. So 6 is 3 times 2, and 15 is 3 times 5, and 21 is 3 times 7. It sounds like a 3 goes into all of those terms. Just like the previous problem, x cubed and x squared and x Same exponent, so we're going to have a GCF of x, because x is the smallest exponent. And then to figure out what still remains in our parentheses, we divide. 6 divided by 3 is 2. We had 3 x's, we took out 1, now we have 2. 15 divided by 3 is 5. We had 2 x's, we took out 1, so we still have 1. 21 divided by 3 is 7. We had 1 x. It's now out in front of our parentheses. We don't need to write an x again. Number 7. A few more variables. And again, worst comes to worst, we can write this all out. So I am going to write out longhand, and it is 2 times 2 times 2 times x times x times x times y. That's our 8x cubed y. We can do the same thing with the 24, and it is 2 times 2 times 2 times 3 times x times x times y times y times y times y. So I'll have to move my problem number 8 here in a minute, and it's okay. But as we look at this, I wrote out all of the variables. I expanded it out. And no, I don't want to do that every single time, and neither do you. But what do we have in common with all of them? Well, there's a 2 here in both of them. There's another 2 that's in both of them. There's another 2 that's in both of them. We have an x, 2 x's actually, that are in common. And we have 1 more. So our greatest common factor is going to be the value that we circled here. It's 2 times 2 times 2 times x times x times y. And if we simplify that, then what we end up with is we end up with 8x squared y. And then that's our GCF. So what is going to go in our parentheses? Well, the only value that we don't have circled in the first term is x. And over here in our second term, we have the minus 3 y times y, which is y cubed. So I'm going to move problem number 8 over to its own page here. And let's do this one without writing it all out. So in this particular case, once again, what we need to look at is, what's the biggest number that divides into 15 and 18? Well, the biggest number that divides into 15 and 18 evenly is 3. In terms of our exponents here, we have an x to the 5th here, and we have an x squared there. Remember that we take the smallest exponent. We have y cubed and we have y squared. Once again, we take the smallest exponent. I had a brief interruption, so I need to go back on this just for a second and refresh my memory on what happened. We took out the greatest common factor for the number 3. 3 goes into both 15 and 18 evenly, and it's the biggest number. We took the smallest exponent between x to the 5 and x squared. We took the smallest exponent between y cubed and y squared. Notice that there's a z in our second term, but there isn't a z in the first term. We cannot take any value out there. There's no GCF that has a z in it. So now we want to finish the problem, and what we can do is 15 divided by 3 is 5. X to the 5th divided by x squared. We had 5 x's, we took out 2, which means that we still have 3. We had 3 y's, y cubed divided by y squared. We had 3 y's, we took out 2, now we have 1. On our second term, 18 divided by 3 is 6. We had 2 x's, we took them out. We don't need to write any x's. We had 2 y's, we took them both out. But we do have a z on our term there that we do need to include. It wasn't part of our GCF. Finally, on our last example here, We have 2x squared minus 5y to the 7th plus 9z cubed. Well, when we look at the numbers here to find our GCF between 2, which is a prime number, 5, which is a prime number, and 9, which isn't a prime number, 2 is 2 times 1, 5 is 5 times 1, and 9 is 3 times 3, we have no numbers in common. Well, it turns out that in our first term with the x squared, and in our second term with the y to the 7th, and our third term z cubed, we also do not have anything in common. So what happens when we don't have anything in common is that we say that this polynomial is prime. So now you've seen the notes. Go ahead and work on some practice problems. You need to practice the factoring, especially if you've forgotten it from 2 years ago. Good luck, and we'll talk about it soon.